The Dassault Rafale exists because France decided that compromising on fighter design was more dangerous than going bankrupt trying to build one alone. In the early 1980s, when every other European nation was pooling resources and splitting worksheets for what would become the Eurofighter Typhoon, France looked at the requirements, air superiority optimized, carrier operations as an afterthought, nuclear strike not even on the agenda, and walked away from the table. They didn't walk away because of pride, though there was plenty of that. They walked away because their national defense strategy, built on independent nuclear deterrence and power projection through carrier aviation, couldn't survive design by committee. The aircraft that emerged from that decision is the Rafale, and it represents the most expensive bet any Western nation has placed on aerospace autonomy since the Cold War ended. Every composite panel, every line of flight control code, every sensor fusion algorithm is a calculation that France could build a genuinely multi-role combat aircraft without American engines, British avionics, or German work-share agreements. Whether that calculation pays off depends entirely on whether you measure success in export contracts or strategic independence. Understanding the Rafale means understanding what France needed in the late 20th century. A single airframe capable of nuclear strike, fleet air defense, close air support, reconnaissance, and buddy-buddy refueling, all while operating from a carrier deck that's 2/3 the length of an American supercarrier. It's a requirements list that sounds less like aircraft design and more like wishful thinking, but the French had done this before. The Mirage series proved that a mid-size aerospace industry could produce world-class fighters if it accepted that every design would be a compromise with physics, and that exports would determine whether the production line stayed open long enough to recoup development costs. But the Mirage generation was reaching the end of its operational life, and the threats were evolving faster than incremental upgrades could manage. The Soviet Union was fielding the MiG-29 and Su-27, both of which could outmaneuver anything Europe had in service. American Teen Series fighters, the F-14, F-15, F-16, F-18, were setting new standards in avionics integration and beyond visual range combat. If France wanted to maintain an independent defense posture into the 21st century, it needed an aircraft that could match those capabilities across every mission profile the Armée de l'Air and Marine Nationale required. The alternative was buying American, which meant accepting that Washington could veto your military operations by withholding parts, or joining the Eurofighter Consortium, which meant your nuclear-capable naval fighter would be designed by a committee that included nations without carriers or nuclear weapons. So, in 1986, Dassault began work on what was then called the Rafale, a demonstrator, a technology test bed that flew to prove the design philosophy could work. The production aircraft that followed, Rafale C for the single-seat Air Force variant, Rafale B for the two-seat trainer and strike version, Rafale M for the carrier-capable model, didn't reach operational service until 2001, nearly 2 decades after France walked away from the Eurofighter program. That development timeline tells you everything about the engineering challenge involved. This wasn't iterating on an existing design. This was building an entirely new technological ecosystem from scratch, because self-reliance means nothing if critical components come from suppliers who answer to foreign governments. If detailed technical breakdowns of aviation design and the strategic calculations behind going it alone interest you, subscribe. I've got more of these coming, and the decisions nations make about defense autonomy rarely get simpler than this. The design philosophy Dassault settled on was delta-canard, a configuration that pairs a triangular delta wing with small foreplanes mounted ahead of the main wing. Deltas offer high structural efficiency and plenty of internal volume for fuel, which matters when you need range for deep strike missions and loiter time for fleet air defense. The downside is that pure deltas traditionally suffer at low speeds, exactly where you don't want problems when landing on a carrier or maneuvering in a dogfight. The canards solve this by generating additional lift ahead of the center of gravity, improving pitch authority and allowing the main wing to operate at higher angles of attack without stalling. It's an aerodynamic solution that the Swedes used on the Gripen and the Europeans would use on the Typhoon, but Dassault added close-coupled canards positioned near the main wing rather than far forward. This creates a vortex interaction between the canard and the wing that increases lift across a wider range of speeds and angles of attack, giving the Rafale the kind of slow-speed handling you need for carrier approaches and the high-alpha maneuverability you want in a within-visual-range fight. The airframe itself is a study in managing weight while maintaining strength because carrier operations are unforgiving. Every landing is a controlled crash at descent rates that would be considered a hard landing on a runway, and the arrestor hook has to withstand deceleration forces that would rip apart anything not built for it. Dassault used a semi-monocoque structure with substantial composite material integration. Roughly 40% of the airframe by weight is carbon fiber composites, including the wings, fuselage sections, and canards. Composites offer better strength-to-weight ratios than aluminum and don't corrode in salt spray, which extends service life for carrier-based aircraft. But composites are expensive to manufacture and difficult to repair in the field, so the decision to use them extensively was a bet that the performance advantages and reduced maintenance costs would outweigh the higher production and training expenses. The landing gear tells you Dassault was serious about naval operations from the start. The nose gear is built to handle catapult launch stresses with a reinforced tow bar attachment and a launch bar that connects to the carrier's catapult shuttle. The main gear has to absorb the impact of arrested landings without collapsing, so it's built heavier and stronger than what you'd need for land-based operations alone. This adds weight the Air Force variants don't strictly need, but building separate airframes for land and carrier use would have eliminated the economies of scale that make a small production run remotely affordable. So the Rafale C and B carry structural reinforcement around the landing gear that exists solely because the Rafale M needs it. That's the compromise you accept when one airframe has to do everything. Propulsion comes from two Snecma M88 turbofan engines, and here's where French independence costs weight and performance. The M88 was designed alongside the Rafale, specifically to meet French requirements, because using American engines, Pratt & Whitney or General Electric, would undermine the entire point of strategic autonomy. Each M88 produces about 75 kilonewtons of thrust with afterburner, giving the Rafale a thrust-to-weight ratio around 0.96 at a typical combat load. That's respectable, but not exceptional. An F-16 with a single F-110 engine achieves similar thrust-to-weight, and twin-engine designs like the F-15 or Su-35 exceed it significantly. The M88's real advantage is fuel efficiency and a relatively low infrared signature for a fighter engine, both of which matter more for sustained operations than for airshow demonstrations. But the engine's moderate thrust means the Rafale isn't going to out-accelerate or out-climb American or Russian heavyweights in a straight-up energy fight. Dassault designed around this limitation by optimizing for sustained turn rate and instantaneous maneuverability, rather than pure speed or climb performance. The engine's bypass ratio sits around 0.3, which is low even for a fighter engine. Most modern turbofans aim higher to improve fuel efficiency and reduce noise. The M88's low bypass ratio prioritizes thrust response and high-altitude performance, characteristics you want in an air superiority fighter that might need to intercept high-flying bombers or win a vertical scissors fight. The trade-off is higher fuel consumption during certain flight regimes, which cuts into range and loiter time. To compensate, Dassault gave the Rafale substantial internal fuel capacity, roughly 4,700 liters in the Air Force variants, and slightly less in the Rafale M, where internal volume is consumed by reinforced structure and the arresting hook mechanism. With external tanks, total fuel load can exceed 9,000 liters, giving the Rafale enough range for deep penetration strikes without aerial refueling, though that assumes you're willing to sacrifice some maneuverability and radar cross-section reduction by hanging tanks and weapons on external hardpoints. The flight control system is fully digital fly-by-wire with no mechanical backup, which is standard for modern fighters but was still relatively new technology when Rafale development began. The system uses a quadruplex architecture, 4 independent computers cross-checking each other's outputs, to ensure that a single failure won't send the aircraft into an uncontrollable departure. This level of redundancy is necessary because the Rafale's relaxed static stability design means the aircraft is aerodynamically unstable in certain flight regimes and requires constant computer correction to stay controllable. The advantage of instability is responsiveness. The aircraft wants to maneuver, and the flight control computers just have to manage how much and how fast. Pilots report that the Rafale feels lighter and more responsive than its size and weight would suggest, particularly in the slow-speed regime, where the delta-canard configuration and fly-by-wire integration provide handling characteristics that approach the best fourth-generation fighters. Where the Rafale genuinely innovates is in sensor fusion and avionics integration, the unglamorous work of making different sensors talk to each other and present the pilot with a coherent picture rather than a dozen separate displays demanding attention. The RBE-2 radar, originally a passive electronically scanned array, upgraded to an active electronically scanned array in later production standards, provides the primary sensor picture, but it's supplemented by the Optronique Sector Frontal, an infrared search and track system mounted ahead of the windscreen. The OSF combines an infrared sensor for passive detection and tracking with a laser rangefinder for targeting, giving the Rafale a way to detect and engage targets without emitting radar signals that would announce its presence. This passive detection capability matters more in contested airspace, where turning on your radar is an invitation for every surface-to-air missile system in range to start calculating firing solutions. The SPECTRA electronic warfare suite integrates radar warning receivers, laser warning sensors, missile approach warning systems, and active jamming transmitters into a system that's supposed to detect threats, classify them, prioritize them, and deploy countermeasures automatically if the pilot doesn't intervene. In theory, this reduces pilot workload during the most dangerous phase of a mission, penetrating defended airspace, by letting the aircraft's computers manage the electromagnetic battle space while the pilot focuses on navigation and weapons employment. In practice, the effectiveness of any electronic warfare system is classified, updated constantly as new threats emerge, and depends entirely on whether your threat library includes the specific radar or missile system trying to kill you. What's documented is that SPECTRA uses active cancellation techniques, generating radar signals designed to interfere with enemy radar returns, theoretically reducing the Rafale's effective radar cross-section without the weight and performance penalties of shaping the airframe for stealth. Whether this works against modern air defense systems is the kind of question that only gets answered during actual combat, and the answers stay classified for decades. The cockpit is built around a wide-angle holographic heads-up display and 2 large color multifunction displays that replace the dozens of individual gauges and indicators that cluttered earlier fighter cockpits. The layout is designed so that critical flight and sensor information stays within the pilot's scan pattern without requiring excessive head movement, which matters when you're pulling high-G maneuvers and your helmet weighs several kilograms with the mounted display and night vision equipment attached. The hands-on throttle and stick design puts essential controls on the throttle and control stick, so the pilot can manage weapons, sensors, and countermeasures without moving their hands away from the primary flight controls. This design philosophy, reduce workload, increase situational awareness, let the pilot focus on tactics rather than systems management, is what every modern fighter aims for. But execution varies. Pilots who've flown both the Rafale and its contemporaries generally rate the Rafale's cockpit favorably for ergonomics and information presentation. though some note that the sheer number of functions accessible through the HOTAS controls creates its own learning curve. For weapons employment, the Rafale carries up to 9 tons of ordnance across 14 external hardpoints, though loading it to maximum capacity turns it into a truck rather than a fighter. Typical loadouts depend on the mission. Air-to-air configurations might include 4 Mica medium-range missiles, 2 Iris-T or Magic short-range missiles, external fuel tanks, and a targeting pod. Strike missions swap the air-to-air loadout for precision-guided bombs, cruise missiles, or anti-ship missiles, depending on the target set. The Rafale can employ the Scalp cruise missile for standoff strikes against heavily defended targets, the AM-39 Exocet for anti-ship missions, and the ASM nuclear missile for strategic deterrence missions, the latter being a capability that precisely 0 of France's Eurofighter partners required. The nuclear strike role imposes specific requirements on avionics and clearances because delivering a nuclear weapon requires navigation accuracy, systems reliability, and operational security that go well beyond dropping conventional ordnance. The Rafale entered service with the Marine Nationale in 2001 and the Armée de l'Air in 2006, after delays that pushed initial operational capability well past the optimistic projections from the 1980s. Early operational experience revealed what every complex fighter program discovers. The aircraft works mostly, but the promised capabilities require software updates, sensor integration fixes, and weapons clearances that take years to complete. The first-generation Rafale F-1 standard was essentially limited to air-to-air missions with the Mica missile and basic air-to-ground capability with unguided bombs. Useful, but hardly the omnirole capability Dassault advertised. The F-2 standard, introduced in 2005, added precision-guided weapons, reconnaissance pods, and improved sensor integration. The F-3 standard and its subsequent incremental updates, F-3R, F-3+, and the current F-4 standard, progressively added new weapons, upgraded the radar, improved SPECTRA's threat library, and integrated helmet-mounted displays that finally gave Rafale pilots the kind of off-bore sight targeting capability that contemporaries like the F-16 and Typhoon had fielded years earlier. This incremental capability growth is standard for modern fighters, which are designed to be upgraded throughout their service lives. But it meant that France spent most of the 2000s operating a fighter that cost as much as a truly 5th-generation design, but delivered 4th-generation plus capabilities. The strategic bet was that continuous upgrades would keep the Rafale relevant for decades, amortizing the development costs across a longer service life. But that bet required 2 things: export sales to sustain production and fund upgrades, and combat deployments that would validate the design in actual operations rather than marketing brochures. Combat validation came faster than export success. The Rafale's first real combat deployment was Operation Harmattan over Libya in 2011, where French Rafales flew reconnaissance, ground attack, and air superiority missions against Libyan government forces. The Rafales operated from both land bases and the carrier Charles de Gaulle, demonstrating the flexibility that justified building a common airframe for both services. Pilots reported that the SPECTRA system and OSF infrared sensor allowed them to operate in contested airspace without relying exclusively on radar, reducing their vulnerability to surface-to-air missiles. The precision-guided weapons performed as expected, and the aircraft's range allowed sustained operations without excessive tanker support. Libya wasn't a high-threat environment. Libyan air defenses were degraded within the first week, and the Libyan Air Force never seriously contested coalition air superiority, but it proved the Rafale could execute the missions France needed it to fly. Subsequent deployments over Mali, Iraq, and Syria put the Rafale into more sustained operational tempos, with aircraft flying multiple sorties per day for weeks at a time. Maintenance crews reported that the Rafale's reliability was decent for a modern fighter. Not exceptional, but better than some of the horror stories that plagued early Typhoon deployments. The composite airframe held up well under harsh conditions, justifying Dassault's decision to accept higher production costs for reduced long-term maintenance. The M88 engines proved reliable, though their moderate thrust meant heavily loaded aircraft needed longer takeoff rolls and careful energy management during combat maneuvering. Pilots praised the sensor fusion and cockpit layout, though some noted that the HOTAS controls were less intuitive than competing designs, requiring more training time to achieve proficiency. The combat record established that the Rafale works, which sounds like faint praise until you consider how many fighter programs fail to reach that basic threshold. The aircraft can execute air-to-air, air-to-ground, reconnaissance, and nuclear deterrence missions from land bases and carriers, often during the same deployment. It can operate in contested environments with modern air defenses, though whether it could survive against truly cutting-edge Russian or Chinese integrated air defense systems remains theoretical. What the combat record doesn't prove is whether the Rafale is worth the cost compared to alternatives, because cost-effectiveness depends on what you're comparing it to and what you value. Given its combat record and the costs involved, roughly 40 billion euros for development and production, was France's bet on independence justified, or should they have compromised and joined a multinational program? Let me know what you think in the comments. If you measure purely by unit cost and capability, the Rafale struggles to justify itself against American alternatives. An F-35A costs roughly the same as a late standard Rafale, but offers genuine low observable stealth, more advanced sensor fusion, and integration into a global sustainment network that France can't match. An F/A-18E F Super Hornet costs less and provides similar multi-role capability with better parts availability and larger weapons payload. But those comparisons assume France is willing to accept American export controls, technology transfer restrictions, and the political reality that buying American fighters means your Air Force operates at Washington's pleasure. If a conflict arose where American and French interests diverged, the F-35's logistics chain runs through Fort Worth and the F-18s through St. Louis, which means France would be flying American aircraft on American terms. The Rafale's logistics chain runs through France, and that autonomy is the entire point. Compared to European alternatives, the Rafale holds its own. The Eurofighter Typhoon offers better high-altitude performance and potentially superior air-to-air capability. But it's a consortium product with work-share agreements that make upgrades and modifications a bureaucratic nightmare requiring four-nation consensus. The Gripen costs less and offers impressive performance for a lightweight fighter, but it uses an American engine and relies on international suppliers for critical components, which undermines the independence argument. The Rafale is the only Western fighter outside the American defense ecosystem that offers genuine strategic autonomy, which is either priceless or pointless, depending on your perspective on France's role in European defense. Export sales were supposed to validate the Rafale's commercial viability, and for 2 decades the results were brutal. Nations that France courted, South Korea, Singapore, Morocco, Brazil, Switzerland, repeatedly chose American or European alternatives, often citing lower costs or better technology transfer agreements. The Rafale earned a reputation as an excellent aircraft that nobody could afford, and Dassault's insistence on maintaining French control over upgrades and technology transfer made the aircraft politically complicated for nations seeking to develop their own aerospace industries. The breakthrough came in 2015 when Egypt ordered 24 Rafales, followed by Qatar's order for 36, India's for 36, and subsequent orders from Greece, Croatia, Indonesia, and the United Arab Emirates. These export sales didn't just fund continued production, they validated the capability gap between the Rafale and cheaper alternatives, proving that nations facing genuine security threats were willing to pay for the Rafale's combination of sensor fusion, weapons flexibility, and operational availability. The Indian sale is particularly telling. India evaluated the Rafale against the Typhoon, F-16, F/A-18, Gripen, and Russian options through a procurement process that lasted nearly a decade and became a political controversy that toppled defense ministers and generated corruption allegations that persist years later. India ultimately chose the Rafale, citing superior performance in Indian operating conditions, high-altitude air bases, extreme temperatures, and the need to operate independently of foreign logistics support during a potential conflict with Pakistan or China. The decision validated Dassault's claim that the Rafale's design integration and systems maturity provided real advantages over competitors, even at higher unit costs. What the Rafale demonstrates is that France's bet on independence has worked barely, and only because Dassault executed the engineering challenge well enough that the aircraft's capabilities justify its costs for nations that value autonomy over affordability. The Rafale will never achieve the production numbers of American Teen Series fighters or the F-35. Current projections suggest total production will reach perhaps 700 aircraft over the program's lifetime, compared to thousands of F-16s or the projected thousands of F-35s. But those 700 aircraft provide France with exactly what it needed: an independent air combat capability that doesn't require permission from Washington, Brussels, or Moscow to operate, upgrade, or deploy. Looking forward, the Rafale's upgrade path is mapped through the F-5 standard planned for the late 2020s, which will integrate new engines with improved thrust, enhanced connectivity for networked operations, and potentially some degree of unmanned wingman control capability. These upgrades are expensive, collectively costing billions of euros, but they extend the Rafale's service life into the 2050s and maintain its relevance against evolving threats. The fundamental question is whether incremental upgrades to a 4th generation plus design can keep pace with dedicated 5th generation and emerging 6th generation platforms that incorporate low observable stealth and fundamentally different operational concepts. France is hedging this bet by participating in the Future Combat Air System program with Germany and Spain, developing what's nominally a 6th generation fighter to replace the Rafale starting in the 2040s. Whether that program succeeds or collapses under the weight of its own complexity and multinational workshare disagreements remains to be seen. The Rafale's legacy isn't measured in production numbers or export sales, though those matter. Its legacy is proving that a mid-sized nation with a sophisticated aerospace industry can develop a genuinely capable, modern fighter independently, if it's willing to accept the financial and opportunity costs involved. France spent an estimated 40 billion euros developing and producing the Rafale, money that could have bought more F-16s, F-18s, or contributed to the Eurofighter program while funding other national priorities. What France bought instead was the capability to conduct military operations without seeking American approval, to maintain an independent nuclear deterrent, and to project power through carrier aviation on French terms. Whether that's worth 40 billion euros depends entirely on whether you believe strategic autonomy has a price, or whether it's the one thing you can't afford to compromise on. If you found this analysis useful, a like helps more people discover these deep dives into the strategic and technical decisions that shape modern air power. Thanks for watching.